Hi friends, this is Soft Reason. We will be doing something like this in this lesson. Okay, this is a shear wall and a Raft Foundation to carry a lift or an elevator of weight 70 kilo Newton per meter square. So if you have not subscribed to my channel, kindly subscribe, like the video and share the video. So let's quickly go into the lesson. You click on it. Once you click on, we change the okay this project name is existing. Okay, so let's add one to it. Okay, all right, so we click on UKBS 8110 import. All right, so you click on your grid, click on the board. Okay, in the direction one axis, we will change this place to 750. That's one comma, and we will have 1000. That's one comma, and 750 times 1. Okay, so in direction to axis we will have 500 times 1. Okay, the bubble extension remains the same, 2000. Okay, and so click on okay. So we will have something of this nature. This is the space of 1000 for the entrance into the elevators hall. Okay, and so what we need do now is go to building, insert story. We will be having 5 story. Okay, go to building, edit story. Our first story will be 3200 millimeter, and this will be 3000. The third one will be 3000, while the fourth will be 2800, and we still have 2800. Okay, as move as normal story. Okay, our dimension, remove the first of 600 millimeter of topsoil because you are using Raft foundations. Okay, so you click on okay. All right, so we go to level 1. Okay, the level 1, you activate your shower. We want to use shower of 225. Then select the center. Okay, and change it to 112.5. that is half of 225. Okay, 112.5. okay, and so we will click first point. We will save the project. Okay, we will generate this member to other stories. Okay, and we click on this wall 1. You hold down your shift key. Okay, make sure you hold down your shift key. Click on the wall 5. Okay, and then you click on building. Okay, generate story. You select story 2. Okay, and hold down your shift key, select story 5. Okay, then click OK, and then yes. then you close. Alright, so once again we check it in 3D. Okay, alright, so this is how it looks. Okay, alright, so the next thing we need to do is we have to save the project again. Okay, we will navigate to the plan view of story 5. Okay, then we insert slab. The thickness of our slab will be 150 millimeter. Okay, we will use flat roof. Okay, and the imposed load we will use this. We update and insert your slab. Alright, you close it, undo it. We are going to insert it in a way that it covers the entire hull of the elevator. $150 flat roof. We use this. Okay, go back to general. Okay, but you click. What you need to do is use axis region. Okay, you select axis region. Okay, then you hold down your control key, you select this, and select this, then you release your hand to insert your slab. Okay, and so you close this and as well closed this. Okay, and then you want to run a line load on the slab. You click on slab load. Okay, and then you choose this and put 10 kilonewton. Okay, alright, then you closed. The next thing you do, you go to analysis, you go to building analysis. Okay, in the building analysis, you check your parameter, check your foundation depth. You want to use 160 as the soil bearing capacity. Okay, and then we can't decide to say just write elevator. Okay, alright, click on OK, go to your loading. We won't be using a horizontal load because the lift is not exposed to wind. Okay, so you click on OK and OK. Alright, you can change material here, edit material. What we have here is concrete wall. Okay, we will use C16/20 in this design. You apply to all member. Okay, the concrete wall, we will check Y10, Y12, and 16. Okay, the next thing we need to do is our link. You uncheck all of this. Okay, we go to foundation. Okay, all right, we go to our analysis, building model check. Having zero error, closed, and you start analysis. Video analysis completed successfully. You okay? All right, and closed. Okay, if you want to check whether the walls are designed, you will enable any of these story. You can see walls here. Expand this or click on it, right click, and then you select column, section, design, and detailing. You can see all the walls have been designed successfully. Okay, so we close this for now. You navigate to story 0. We want to fix our slab for our foundation analysis and design, but before then we click on save to save the project. Alright, and so the next thing we need to do is we are at story 0. Okay, and so we want to insert a slab for the Raft Foundations analysis and design using finite element. Okay, so you click on slab. Okay, once you click on slab, we want to have a thickness of it is a foundation's thickness of 400. Okay, and then the concrete cover will be 60, and then you come to load. Now in this place of load, you use enter value. Okay, so that in place of that load you will put 70 kilonewton per meter square, because this is the weight of the lift or elevator, and the weight of an elevator depends on, as in is all goes to the foundation, and so that is where the load is actually acting, while the walls only guide the elevator. Okay, so impose load, we will use an impose load of 5 kilonewton per meter square. Okay, so we will insert our slab. You hold down your control key, you click on the first one, click on the second, you click on the third. Okay, and then you release your hand to insert it. Okay, alright, we need to insert for in case of overturning, and so we are going to insert from the shear wall 800 millimeter outward. Okay, and for us to do that, we will need to come back to this point, and then we will click inside this type. Okay, then select this section. Okay, once you select it, you come to L count, type 800. Okay, click the first point, click the second point, and then insert it outside. Okay, you do the same thing. Alright, you closed. You view your project in 3D. Okay, so this is it. Okay, and so we go back to plan view. Okay, now we want to run the Raft Foundation analysis and design. Okay, but by then we will save the project. Alright, so we will be running the analysis, finite element analysis now. So what we need to do now is we go to analysis again, and then you go to FE Raft Foundation analysis. You click. Alright, at this point you can see this is our subgrade coefficient. Okay, you can pick some other subgrade coefficient depending on the soil texture of your area. Okay, so we will be using 50,000 kilonewton per meter cube. Okay, you select this subgrade and then include this in the finite element analysis. Apply live load reductions or combinations. Alright, so you can also edit material too. Yeah, you click on this point to check the material if they are properly edited. Okay, okay. Alright, so after which you just click on Raft Foundations Mesh and Analysis. After Raft Foundation Mesh and Analysis, okay, and then you hit on it. It will take some time to prepare the finite element. So that it is done, you just have to scroll to zoom it out. After which the next thing you need to do is you will generate model. Okay, but by then let us reduce the plate element size to 500. Okay, and then hit on generate model. Alright, it has generated the model successfully. Okay, so the next thing you need to do is you have to close this window so as to transfer you to where you run other analysis as well as design. Alright, it will show you to confirm your allowable stress of soil, because originally we were on this tab, floor mesh and analysis, now post analysis process and report. Okay, so what you need to do is click on analysis post processing. Okay, alright, you just have to zoom in. Alright, so this is what we have. These are the road transfer to the Raft foundations from the shear wall. Okay, so if you want to see the animation and the movement of the load, you just hit on your animation button. You can see the movement of the load. Okay, alright, you stop it and then you click on standard contour. Okay, alright, the standard contour will give you this. Alright, okay, you can also move the positions of this display of this key. Okay, you click on position, you move the position from one point to another. Okay, you can as well increase the size so you can see very well. Okay, alright, it's okay. Now the next thing we need to do is we want to start the design. So we come to bending moment in the global directions. You click on this. Alright, it is showing you the value of the bending moment in kilonewton meter. Okay, in the global direction X, direction Y. Alright, you come to bending in the local directions 1, 2 and 12. Alright, so you can see the volumes. Okay, and then you move your cursor downward, then we used design moment. You see design moment at the bottom, direction 1, bottom direction 2, and design moment at the top, direction 1 and top, direction 2. Okay, the next thing is the required steel area. Okay, so the required steel area in direction 1 bottom, you click. This is what this is giving us. This is the critical level. Okay, 300 and what 5. 0.9 is the required steel area. If you are moving your cursor along this area, it will be showing you what is the value that is on this key. Okay, you can see in millimeter square. Okay, so the critical value is this. Now, how do you determine the reinforcement that can be able to withstand this area? Okay, what do they do? You go to a table. We'll use this table. Okay, so this table has to have the spaces and the diameter of reinforcement as well. Okay, so you find this area. This way is the area. All these 780, 624 are your areas of reinforcement. Okay, corresponding to the spaces. Okay, and so what we have here as the critical area is 305. Okay, so you will find 305. Okay, 305, and then you can be able to know the diameter of reinforcement you want to use. Okay, so we have 312 here. So in this design we can use Y10 at 250 millimeter space. Okay, for our bottom direction 1 reinforcement. Okay, that's what it's telling us. So because we are having 305, and so 312 can be able to pass, or we can use Y12 at 300 and what 300 mm spacing. Okay, you can use a Y12 as 300 spacing, which is in line with area 377, which is greater than 305. Okay, so any of these two bar can go. Okay, so we minimize this. We go to the area direction to bottom. We click. We still have not too far. Okay, 310 as well. So we can still use the same reinforcement as before. Okay, so area diameter 1 top is even lesser. Okay, so we can use that same reinforcement selected for both the top and bottom reinforcement in both directions. Okay, 96. Alright, so this is the design. Let us check the soil pressure. You click on this soil pressure, you can see the graph. Okay, now it is okay. You can see the soil pressure 169.231, less than 224. Okay, if the value you're having here is greater than the value you're having here, it means the soil is already failing. It's not able to hold the foundation. Okay, but we can see the critical highest point here, which is 191.506. okay, which is even less than the 224. So the soil is okay. So this is our finite element analysis and design of our Raft foundations. So we have done this successfully. Okay, so we want to leave this window, but by there we can export this to our model. Okay, by clicking on export. Okay, you can also, if you want to export any other design parameters, you can export as well to the model. Okay, and then we close this, click on the OK button. Okay, and closed. It's alright. So at this point we will be looking at generating our drawings. Okay, we will be generating our drawings. So what we need to do is you can still navigate to any of the stories. Go to a plan view. Okay, and then you click on the ROC design, then click on Prota data. It will take some time to load. Okay, Alright, the Prota detail has successfully loaded. So you can't either produce your drawing using creating your drawing by starting by creating a new drawing, okay, whereby you click on this arrow size and then begin to create your drawing one by one, or you can click on auto generate details, okay. And so that is what we are going to do. Click on auto generate details. Once you click on it, draw details dialog, select this column dimensions and check the scale, click on draw. Alright, and just click at any point. Okay, so your drawing has been created successfully. Okay, this is the slab, okay, and these are the stories. You can see story 1, okay, level is 3.2 meter, which is equivalent to 3200 millimeter, okay, and the scale is 150. The same thing applicable to other ones, okay. You check here, you see this is the story 1, okay, showing you the shear walls. So this is the story 1, showing you the details of the shear wall, okay, in that story, okay. You can see the detail of our shear wall. Alright, so after, these are the elevations of the shear wall. The elevation of the shear wall and the bar bending schedule of the shear wall. This length is applicable to, as below you can see, it's applicable to other stories, okay. And also this particular length is also applicable to other stories. And so you can see the bar bending schedule, okay, of the shear wall. So everything is provided for us. And so I want to show you my AutoCAD work on this, okay. So this is the edited work on this. So this is my Raft Foundation. I actually use Y16 to run it so as to not to observe any failure in the future, okay. And so this is the top of the lift, okay, and other necessary drawing, okay. So I hope you learned one or two things in this lesson, and this lesson has helped you in one way or the other. Kindly subscribe and like the video for subsequent lesson and notification.